Grease is a semi-solid lubricant. Grease generally consists of a soap emulsified with mineral or vegetable oil. The characteristic feature of greases is that they possess a high initial viscosity, which upon the application of shear, drops to give the effect of an oil-lubricated bearing of approximately the same viscosity as the base oil used in the grease. This change in viscosity is called thixotropy. Grease is sometimes used to describe lubricating materials that are simply soft solids or high-viscosity liquids, but these materials do not exhibit the shear-thinning properties characteristic of the classical grease. For example, petroleum jellies such as Vaseline are not generally classified as greases. Greases are applied to mechanisms that can only be lubricated infrequently and where a lubricating oil would not stay in position. They also act as sealants to prevent ingress of water and incompressible materials. Grease-lubricated bearings have greater frictional characteristics due to their high viscosity. Properties: a true grease consists of an oil and/or other fluid lubricant that is mixed with a thickener, typically a soap, to form a solid or semi-solid. Greases are a type of shear-thinning or pseudoplastic fluid, which means that the viscosity of the fluid is reduced under shear. After sufficient force to shear the grease has been applied, the viscosity drops and approaches that of the base lubricant, such as the mineral oil. This sudden drop in shear force means that grease is considered a plastic fluid, and the reduction of shear force with time makes it thixotropic. It is often applied using a grease gun, which applies the grease to the part being lubricated under pressure, forcing the solid grease into the spaces in the part. Thickeners. Soaps are the most common emulsifying agent used, and the selection of the type of soap is determined by the application. Soaps include calcium stearate, sodium stearate, lithium stearate, as well as mixtures of these components. Fatty acids derivatives other than stearates are also used, especially lithium 12-hydroxystearate. The nature of the soaps influences the temperature resistance, water resistance, and chemical stability of the resulting grease. Powdered solid greases. Powdered solids may also be used as thickeners, especially as clays, which are used in some inexpensive, low-performance greases. Fatty oil-based greases have also been prepared with other thickeners, such as tar, graphite, or mica, which also increase the durability of the grease. Engineering assessment and analysis of greases. Lithium-based greases are the most commonly used. Sodium and lithium-based greases have higher melting point than calcium-based greases but are not resistant to the action of water. Lithium-based grease has a dropping point at 190 to 220 degrees Celsius. However, the maximum usable temperature for lithium-based grease is 120 degrees Celsius. The amount of grease in a sample can be determined in a laboratory by extraction with a solvent followed by, for example, gravimetric determination. Additives. Solid lubricating additives including PTFE, graphite, and molybdenum disulfide are added to some greases to improve their lubricating properties. Gear greases consist of resin oil, thickened with lime and mixed with mineral oil, with some percentage of water. Special-purpose greases contain glycerol and sorbitan esters. They are used, for example, in low-temperature conditions. Some greases are labeled EP, which indicates extreme pressure. Under high pressure or shock loading, normal grease can be compressed to the extent that the greased parts come into physical contact, causing friction and wear. EP grease contains solid lubricants, usually graphite and/or molybdenum disulfide, to provide protection under heavy loadings. The solid lubricants bond to the surface of the metal, and prevent metal-to-metal contact and the resulting friction and wear when the lubricant film gets too thin. Copper is added to some greases for high-pressure applications, or where corrosion could prevent disassembly of components later in their service life. Capaslip is the registered trademark of one such grease produced by Molyslip Atlantic Limited, and has become a generic term for anti-seize lubricants which contain copper. History: grease from the early Egyptian or Roman eras is thought to have been prepared by combining lime with olive oil. The lime saponifies some of the triglyceride that comprises oil to give a calcium grease. In the middle of the 19th century, soaps were intentionally added as thickeners to oils. Over the centuries, all manner of materials have been employed as greases. For example, black slugs or iron otter were used as axle grease to lubricate wooden axle trees or carts in Sweden. Classification and standards, jointly developed by ASTM International, the National Lubricating Grease Institute and SAE International, Standard ASTM D4950 Standard Classification and Specification for Automotive Service Greases was first published in 1989 by ASTM International. It categorizes greases suitable for the lubrication of chassis components and wheel bearings of vehicles, based on performance requirements, using codes adopted from the NLGI's ECASES and Wheel Bearings Service Classification System LA and LB. Chassis lubricants, GA, GB and GC, wheel bearings. A given performance category may include greases of different consistencies. The measure of the consistency of grease is commonly expressed by its NLGI consistency number. The main elements of standard ATSM D4950 and NLGI's consistency classification are reproduced and described in standard SAE J310 Automotive Lubricating Greases published by SAE International. Standard ISO 6743-9 Lubricants, Industrial Oils and Related Products Classification Part 9, Families first released in 1987 by the International Organization for Standardization, establishes a detailed classification of greases used for the lubrication of equipment, components of machines, vehicles, etc. It assigns a single multi-part code to each grease based on its operational properties and its NLGI consistency number. Other greases silicone grease Silicone grease is an amorphous fumed silica thickened, polysilicon sand-based compound, which can be used to provide lubrication and corrosion resistance. Since it is not oil-based, it is often used where oil-based lubricants would attack rubber seals. Silicone greases also maintain stability under high temperatures. They are often used, in pure form or mixed with zinc oxide, to join heat sinks to computer CPUs. Fluoroether-based grease Fluoropolymers containing COC bonds for flexibility are soft, and often used as greases in demanding environments due to their inertness. Foamblin by Sylvace-Alexis and Crotox by DuPont are prominent examples. Laboratory grease Apuzon, silicone-based, and fluoroether-based greases are all used commonly in laboratories for lubricating stopcocks and ground glass joints. The grease helps to prevent joints from freezing, as well as ensuring high-vacuum systems are properly sealed. Apuzon or similar hydrocarbon-based greases are the cheapest, and most suitable for high-vacuum applications. However, they dissolve in many organic solvents. This quality makes cleanup with pentane or hexanes trivial, but also easily leads to contamination of reaction mixtures. Silicone-based greases are cheaper than fluoroether-based greases. They are relatively inert and generally do not affect reactions, though reaction mixtures often get contaminated. Silicone-based greases are not easily removed with solvent, but they are removed efficiently by soaking in a base bath. Fluoroether-based greases are inert to many substances including solvents, acids, bases, and oxidizers. They are, however, expensive, and are not easily cleaned away. Food-grade grease Food-grade greases are those greases that come in contact with food. Food-grade lubricant base oil are generally low-sulfur petrochemical, less easily oxidized and emulsified. Another commonly used poly-I plus or minus olefin base oil as well. The United States Department of Agriculture has 3 food-grade designations, H1, H2 and H3. H1 lubricants are food-grade lubricants used in food processing environments where there is the possibility of incidental food contact. H2 lubricants are food-grade lubricants used on equipment and machine parts in locations with no possibility of contact. H3 lubricants are food-grade lubricants, typically edible oils, used to prevent rust on hooks, trolleys and similar equipment. Water-soluble greasy analogues in some cases, the lubrication and high viscosity of a grease are desired in situations where non-toxic, non-oil-based materials are required. Carboxymethyl cellulose, or CMC, is one popular material used to create a water-based analog of greases. CMC serves to both thicken the solution and add a lubricating effect, and often silicone-based lubricants are added for additional lubrication. The most familiar example of this type of lubricant, used as a surgical and personal lubricant, is KY jelly. See also. References. This article incorporates text from a publication now in the public domain, Ward, Artemas. The Grocer's Encyclopedia. External links, U.S. Army Corps of Engineers Grease Definition and Application Guide, New Location, navigate to USACE Home, Publications, Engineer Manuals, M1110-2-1424 Lubricants and Hydraulic Fluids, U.S. Army Corps of Engineers Grease Definition and Application Guide.